In this periodic perfection, we're going to be talking about hydrocarbons, specifically alkenes. If you look at alkenes on the reference table, they have at least one double-double bond between two of their carbons. A good example is ethene, and that's what we're looking at here. We have two carbons with a double bond between them. All our naming conventions remain the same regarding the prefixes for the number of carbons. That is not going to change. The only thing that changes at this point is we'll need to tell where our double bonds are. So let's go through and do a quick naming. Here is an alkene. I know that it's an alkene because I have a double bond in it. So first thing I do is I know it's an alkene because of the double bond. Now I'm going to count up how many carbons I have in my main chain of my molecule. And I have 1, 2, 3, 4, 5 carbons. That means that according to table P, 5 carbons means that, whoops, wrong spot. 5 carbons means that I will be using pent for 5. So that means that I have pentene. So good so far. But I need to tell where that double bond is because it's unique. It's the thing that makes this an alkene, not an alkyne. Just like all our other naming conventions, locations are numbers. The only time you use a number is when you're designating a location, just like you would give for your home address. You have a house number or an apartment number, that number is a location. So if I go in and I number up my carbons, I need to look and see, do I want to count from left to right or do I want to count from right to left? I always want to end up with the lowest number. If I count in this direction, 1, 2, 3, 4, 5. My double bond is right after the 3 carbon. However, if I count in the other direction, 1, 2, 3, 4, 5, my double bond is right after the 2, and that 2 is lower than 3, so I'm going to use 2 pentene is my name, 2 pentene, and that's how you name alkenes.